Kings and queens, Linux has a marketing problem. Think about it. When you go into a Starbucks, which is kind of like the epitome of everything bad about Western society, you walk in and you think you're making a decision, but indeed you're not. They give you the tall, the venti, the grande, whatever it is, and then you go in and your mind immediately determines, okay, the one in the middle seems to be the best value. And this is a common marketing trick. It's not just Starbucks who does this. Think about Apple. They give you practically no choice when it comes to your desktop environment. There's very little customization, especially out of the box, and yet they manage to sell tons of their product. They got people lining up at their stores, and what they've really done is taken beautiful pieces of hardware and then they've reduced the amount of customization that users can have. And it is the fundamental misunderstanding in the Linux community of human psychology that is detrimental to the broader uptake of Linux in desktop use. That's my contention. Now, in my case, I started using Linux about 8 years ago. I was on a coding boot camp. It was this overpriced coding boot camp, and everyone there, they had a Mac. And I had my trusty old ThinkPad. I'd left the bank, and I got myself an old ThinkPad, and I just wasn't prepared to spend €2,000 or whatever it may be on a Mac. It's just wasn't something I was about at the time. And so I was kind of in this group, and I'm using Windows subsystem for Linux version 1 at the time, and it was just like installing node modules was hard, and I just felt like my system was holding me back so much. And so a couple of the people on the program, they kind of suggested, why don't you go and try install Linux on this machine? At the end of the day, Mac is Unix based, and so a lot of the commands that the other people in the program were using and a lot of their approaches were going to be suitable on a Linux machine as well. And so I did just that. I installed Ubuntu onto my machine, and from day one, it was just night and day compared to my Windows experience. It's crazy to think you pay for your Windows license, and then when you go to the start menu, they're not only phoning home with all of your data, but they're also loading it up with all kinds of ads and junk. And so now I was in a Linux distribution, which a lot of people watching are going to say, Ubuntu is not good. I'm going to get into distros later. But the point is that where I started with Linux was with Ubuntu, and it helped me be a way better developer. And I was actually shocked at how much better it was using even Linux as a beginner, despite some of the difficulties, which we're going to go through, compared to using Windows. So you don't need to use Windows, okay? Okay, so I mentioned that Linux has a marketing problem. The thing is, when you think about using Linux, people will come at you with, you've got to use Arch, you've got to use Endeavour OS, you've got to use Nix, you need to use whatever it may be. And at the end of the day, what I'd like to just take a step back for a beginner, okay? These are all just Linux. Can we just think about this? So when we talk about a Linux distribution, what we're really talking about is an operating system that uses Linux and is the composition of 9 different things, broadly speaking. These are the categories that I, in my mind, have created. And you don't need to understand every single one of these as a beginner or a newcomer to Linux. They'll make more sense with time. But I just want to introduce that every single Linux distribution has these 9 aspects, and it is the maintainers at a broad level of the Linux distribution who package these all together. That's what becomes the operating system or the distribution. So the first thing that every Linux distribution has is, of course, Linux, or the Linux kernel. Now, the Linux kernel is what manages your hardware and your memory, this CPU scheduling. So when it comes to, for example, the threads, what's going to be executed next, it provides system calls for the user programs. And this is why we call Linux Linux. When we boot into our Linux distribution, there's a compressed Linux kernel in your boot directory. I'm going to show you later. And this is what gets loaded. Okay, so this is Linux, and that's really the foundation. Secondly, you have your GNU tools and libraries. We actually don't refer to Linux, strictly speaking, as just Linux. We call it GNU Linux, and that's because there is the open source GNU project, which has a lot of essential command line tools, which your system would really be unusable without. This suite of tools and libraries, it allows you to interact with files and run programs. The third component is the Initsystem. So the most common one that you'll see is systemd. And this is the first process that runs after the kernel boots. And it manages all the system services and the user sessions. So for example, the firewalls, your Bluetooth, your Wi-Fi, it's the Initsystem or systemd which is spinning these up and managing these. Fourth, you've got a package manager. So every single distribution is going to have a different package manager. If you are in the Red Hat family, for example, then you would use something like DNF. That's the default package manager for Fedora. If you're on Arch, then you would be using Pacman. And if you're on a Debian family or downstream from Debian, which of course includes Ubuntu, and even downstream from that is Pop! OS, which is quite popular for beginners, then you're going to be using the apt or the apt package manager. So it depends on the distribution. The purpose is all the same. The package manager is to install applications, tools, and update. The intention is the same, but of course each distribution has its own package manager which manages that. Next we have system libraries. So when you install a program, ordinarily if we're installing some kind of application into our system, then it will rely on certain system libraries. And the reason for that is it is compiled, and the developers will compile that, or you can compile that, and you install it on your system, and it is expecting certain system libraries to be available. So one of those, for example, is libSSL, which is for encryption, and there's a whole number of these. We don't need to go into too much depth. You just need to understand that your applications, they rely on a certain number of system libraries to be available, and they should be installed in your distribution by default. Next, the sixth component is a user interface. Now, even if you install a headless Linux version, you still have a command line interface. And that's things like bash or zsh, which is what I use. And so you interact with your system via the command line and through a terminal emulator. So that terminal emulator, it allows you to run commands and allows you to interact with the system using those core utils that we mentioned earlier and to invoke other programs. But the thing is, ordinarily on a desktop Linux system, you would also have a graphical user interface. Think about when you have a Mac system, or if you get Windows. Windows doesn't give you really any options. You just get the start menu and you've got all the bloated junk in there, and that's just what you get. There's some limited customization that you can do, but that's sort of the extent of it. When it comes to Linux, there's a whole number of different desktop environments, or there are tiling window managers. So in my case, I use Qtile, but if you're on a system like Pop! OS, it uses the Cosmic desktop environment. Others quite popularly use GNOME or GNOME as it's referred to commonly in Linux. And then also there's things like KDE, which are really fully fledged, great desktop environments. So it's ultimately up to you. And the purpose of this tutorial, though, is not to intimidate you or impose analysis paralysis. None of these matter. We're going to be concerned with only working in the command line, because everything else, all of these user interfaces or these graphical user interfaces, these desktop environments and tiling window managers, they are just a layer on top. So at the end of the day, you could have any one of those. It doesn't matter. What you're really concerned with is understanding how Linux works under the hood, how it actually works, all the commands and everything. To begin with, just take the one that your distribution ships with by default. The seventh component, which forms your Linux distribution, are the applications. So any operating system would be useless without text editors, without web browsers, without an Office suite. The eighth thing is around security and system tools. So the one that is going to really jump out is sudo, and this allows us as the user to run commands as root or escalated privileges. And as a beginner, this is one of the more confusing aspects, because when you're on a Windows system, it'll just pop up and say, allow administrator access. Well, the security and system tools, these are tools which allow for safe operation, privilege control, and protection. And so we don't actually want to always run as the root user, because it's quite We've got a lot of privileges. We want to adhere to the principle of least required privilege. And if you want to get more into this, then you should definitely check out my Arch Linux security video. It's applicable to all Linux, of course, but that video touches on a lot of the security aspects of Linux. The final thing is all of the configuration and scripts, and these are text files and they're scripts that define the system behavior. So this is things like startup services, system-wide environment settings, your network configs. These 9 different components that put together create a Linux distribution. Well, as I mentioned at the start, it's the maintainers who determine the Linux kernel version. They determine the desktop environment. They package it all together. They do a lot of hard work for us, a lot of heavy lifting, and we end up with an operating system. And that's why we call it a distribution. That's a certain distribution of Linux. That's a certain package of Linux. And there's so many of them, right? But I think based on what I've shown you here and what I'm going to show you in a moment, they're all just Linux. So let me further show you what I mean. Okay, so as I mentioned, we're not going to be concerned with the desktop environment. The desktop environment, or the tiling window manager, that's just a layer on top that helps us to interface with our actual system. That could differ from one distribution to the next. So I'm not going to be touching on that. Rather, we're going to be in the command line. And before you say, Rad, only incels use the command line, well, I can assure you I'm not an incel. And the command line is nothing, you don't need to be afraid of it. It's very powerful. Not only is it powerful, oftentimes, in my opinion, and I think a lot of people will agree with me, it's much easier than using a graphical user interface. If you're following along, go into your Linux distro, open the terminal, and you'll be presented with something like this. This is a terminal emulator. I use Alacrity. It doesn't matter what you would like to use. You can use the default terminal emulator that your system comes with. And here I'm using the bash shell. That's the born again shell. And we're logged in. You can see in what is referred to as the prompt, rad is the user, and then at T480, that is the host, or the machine that I'm on is called T480. Okay, so we can see where we are. Just run this command, pwd. The first thing that I'm going to be taking you through is core utils, and we're not going to be able to do all of them, but the GNU project makes all of these utilities available and tools, and this is what you're going to be using, and it's the same across every Linux distribution. What I'm going to do is I'm just going to demonstrate some of these. The first thing that I'm going to do is we've done pwd, which stands for print working directory, but we can also use ls. That's going to list everything which is in the directory at the moment. So we here can see that I've got a few different things. I've got documents, downloads, music, public, and so forth to do. Okay, what about if we want to create a file? Well, we can touch a file and we can just call this a test file.txt. Okay, what does touch do? It creates a file, or if the file exists already, it updates that file. So here you're going to need to use an editor. If you are a newcomer, a lot of people like to use Nano, and so I'm going to open this. I actually don't even have Nano installed. So a lot of people, you probably will out of the box have Nano, but what you can use if you're a genuine Linux hacker is you can use Vim, for example. You can always check which of these tools are installed with the which command. So for example, if I run which nano, okay, so I have NeoVim installed on the machine. So I'm going to use NeoVim, but you could run nano and then the test file. I'm going to say nvim, and then we're going to say test file. Okay, now we're in a blank file, okay? So that's how we would create a file in Linux. We could use the touch command. We can also use the cd command. So I'm going to cd, and I'm going to cd into the root, okay? Here, the root is the very edge, or the very beginning of our file tree, system file tree. If we have a look in here, we're going to see all the directories that are available. And this is the same across Linux distributions. Once again, I'm going to explain each of these in a moment. So if we wanted to change back to our home directory, we can use the tilde. And if I use pwd, we see we're in home rad. So every single one of the users, they get allocated a directory. If you wanted to also, rather than just see what your home directory is, you can also use the whoami command. That's going to tell you your username. You can, for example, make a new directory. So what I'm going to do here is I'm going to say mkdir, and I'm going to make a new directory. It's called test. Okay, and here, for example, it's telling us, okay, the test directory doesn't yet exist. So we can always provide flags to our commands. The P will create the path. And so now we can ls, we can list what's in our test. Okay, and actually I made a mistake there because I made the directory txt. So why don't we remove it? I'm going to say rmdir test txt. Now if we touch a file in our test, and we're going to call it txt. Now I'm going to ls. Okay, we can see it there. I'm going to use one of the commands which is super simple, which is the echo command. So we can say echo and then hello. I'm going to say echo hello world. All right, but what about if we wanted to pipe that? We want to put that into a file. So a single greater than symbol would actually create a new file, but in our case we want to append it to the file. We want to put it into test and then test txt. So now we can use cat, which shows us the contents of a file, and I'm going to cat test txt, and we can see hello world is now inside there. Then just to show you some of the additional core utils, we can look at free. This is going to show you the memory, which is free. So we can always pass, for example, a H for human readable. And here we can see that we're using 4.6 gig of the available memory, and the swap is unused. And we've got 31 gig of memory on this machine. Okay, what about if, so we've looked at free, that looks at our memory. What about if we want to look at what is actually in terms of the disk usage? All right, so we can use df. And here we can see we've got a number of different partitions. However, the one there is 223 gigabytes, and it's about 15% used. Okay, and so I've introduced some of the core utils, and with time you'll just get more familiar with the core utils. You'll understand how to use them better. You can always use man, which is the manual. So if we looked at man ls, then we can have a look in here, and we can, using J and K, I'm moving up and down, you can see all the flags that I've been using. So for example, before we used human readable with the -H, but there are any number of commands. Now we've got the power of our core utils. We've got all these commands at our fingertips. Well, now we can actually navigate our system, but like, how do we do that? We see the prompt, we've got rad at T480, and we can see the tilde. The tilde represents the, as I mentioned, the home directory. But where we're going to start with respect to this is not with the user rad, but rather with the root directory. So what I'm going to do is I'm going to say cd and then /. Every single relative file path always starts with /. We're coming from the root, the very beginning of our file system. Okay, and so if we have a look in here, we can see all of these directories, and these are going to be common across Linux. The directory that we're presently in, denoted by the /, is called the root directory. Everything starts here. Okay, everything in Linux is located under root or comes from root. Okay, so if we wanted to see before ls, I'm going to list, and we're going to say we're in home here. So home is located in the root, and then so is rad. So rad's directory is relative to the root directory. I'm just going to clear. Okay, and now I'm going to ls again. With respect to these directories, which you can see, we have what we call in Linux, the Linux Foundation maintainers actually determine this. This is called the File System Hierarchy Standard, or the FHS. So this defines the directory structure and the content purpose of the directories in Linux. So it's great that we have this standard, because it means that we don't just go into a new Linux distribution. Imagine that every single Linux distribution had a different opinion about what this should look like. So thankfully that's not the case. This is going to be the same directory structure across all Linux distributions. Of course, one or two might tweak things, but generally speaking, this is where they are. And so I've already mentioned that we're in the root directory. Now I want to touch on things like binaries. So the first directory that you can see there, the important thing to note about binaries, these are executables and they are system-wide executable and they're imperative to the system. Okay, so it doesn't matter which user you're logged in as root or as rad or your own user, they are going to be available there. Next, we have the boot directory. And we'll just touch briefly on the boot directory because, importantly, remember when we were going through the components that constitute a Linux distribution? Well, one of the things was the Linux kernel, and it's foundational, right? The Linux kernel lived in a compressed format in the boot directory, and if we have a look in here, we can see we've got a few files, but importantly, the last one there is vm-linuz-linux. So I'm actually just going to have a look at that one. So boot and then VM, and we're going to, once again, we're going to pass, and so it's 16 meg. And just to be aware, this is a compressed Linux kernel, but it also refers to a lot of other modules which are not placed here. They're placed elsewhere, but nevertheless, at boot time, this is what gets referenced, okay? And so the boot directory, you can just imagine it relates to everything which pertains to booting and startup. The next one is dev, and dev refers to device files. Basically, it's a directory of special files that relate to certain devices. They're all virtual files, they're not physically on the disk. It's not too important if you're a beginner, but you will see, for example, dev-null. Some people pipe things into the dev-null if they want to destroy them. There's other things like dev random. It is an infinite sequence of random values. So for example, if we wanted to use cat, then we can say dev and then random. Then it's just going to give us an infinite amount of random characters, okay? So we've looked at bin, boot, dev. Now etc. etc is a very important directory because it contains the core configuration files of the system. So when you're setting up your sudoers and you are setting up your SSH, everything that really pertains to your core configuration of the files and system and administration and services, firewalls and so forth, then the passwords as well, then that's all going to be in etc. Hostname is also there, okay? So we can have a look at that one just out of curiosity. So we can say etc hostname, and we can see the hostname is T480, okay? So that is a configuration file that's set there, and that's what our prompt is showing when it comes to rad at T480. So just you can relate your etc directory to these system-wide configuration files. Okay, and so now let's move along. We can look at the home directory. The home directory we're already a little bit familiar with because we were looking at rad's home before. But if we ls and we say home, then we can see all of the users which are available on this system, okay? I'm going to come back to this a little later when we create a new user, but it's pretty self-explanatory. The home directory is where data and files specific to a user live. Okay, so the next one along there is lib, and lib refers to shared libraries. So recall that earlier I mentioned that there are going to be shared libraries that your system relies on. If we have a look into lib, it's not going to mean much to us as users. These are dependencies you can see that, or libraries that other programs in our system depend on. So you don't need to go and change anything in your shared libraries or your lib directory. Your MNT directory is your mount directory. So this is where if you do an Arch install at some point, or you want to mount any other file systems, you would mount them here and then you would be able to access them. Opt is your optional software. So this is where traditionally the opt directory is where you would install files for third-party applications. So if we have a look in here, we'll see what we've got. Okay, and so I've got Coreboot and also Brave. So these are two things which are third-party software, and so they have some file or some information stored. Proc stands for process and kernel files, okay? And the directory here is all about your processes, and it's used by tools to get system information and that kind of thing. So for example, if you wanted to look at your CPU info, you would say ls and then I'm going to say proc and then CPU. Rather, we're going to cat that. And so in here we have some information about our CPU. Okay. Next, we've got our root directory. Not to be confused with the actual directory that we're already in. So we're in the root directory, right? Denoted by that /. Well, root here actually refers to the home directory of the root user. And it's best practice to not actually be a root user. I've been in a lot of professional situations where people would just use the root user for everything. It's not good. Okay, you want to stay as your user, and then you can use sudo, be part of the sudoers group to escalate. And I'm going to show you in a moment what I mean by that. Now, run is the directory located, as we can see here, on the file system, which is a temporary file system that stores runtime data. So this is for systems and services, and so it holds runtime data relating to specific process IDs and lock files and sockets. You don't need to mess with run, okay? Okay, so next is sbin, and this is the binary. So we already touched at the very beginning of this review of the file system or directory structure. We saw that binaries is where a lot of these core utils, these absolutely imperative commands and tools are stored. Well, sbin is for our administrator binaries, which are restricted to the administrators. Okay, srv is the service data, and it contains data for services provided by the system. So for example, if you have an HTTP server, it'd be good practice to put in the data associated with any website or server in that directory. Next, we've got sys. Sys is a directory. It's actually a virtual file system, and it provides a view into the kernel's device and system information, okay? And then next we've got, I'm going to just touch on tmp and var. So they serve different purposes, but at the end of the day, so they are storage for files. So tmp is your temporary directory, and this is for short-lived files. So apps might put a file there temporarily, and they may do away with it later, all right? Anyone can usually write to the temp directory. So sometimes it's handy to put things in there if you need temporarily just a file or something like that. var, on the other hand, it's variable data that changes over time. So this could be like logs, databases, and caching, and so forth. So it is variable, okay? And so it can be written to as, for example, logs come in from SSH or from your network or something like that. And then the last one there that I just skipped over is USR, or Universal System Resources. We've already touched on sbin and bin. This is where these binaries are, which are executable for your system to operate. Well, then the kind of non-essential executables go into the USR, and I'm going to just ls USR, and in here we'll see what we've got. So we've got bin, we've also got local and share. So you will see that all of these are going to be looked at when your system, when you try and run a command, it's going to refer to your path. And just to be clear, your binaries or your executables are going to be located in your bin directory. And if you're a root administrator, in your sbin. And then if you're a normal user, it's going to be looking in bin and also into this Universal System Resources and then bin. Okay, so we can look at our path. I'm going to simply echo and then path. And you can see here, what is the path of you should definitely do this on your own system. So for example, in my case, my user rad is going to look into rad's .local bin, and then it's going to look into Universal System Resources local bin. If it can't find the program there or the tool, or the utility, it's going to look into USR bin. If it can't find it there, look into bin. And so that's a lot of bins, right? So you get the idea. The USR, you can just think of the Universal System Resources as the non-essential executables on your system, all right? If I say which and then nvim, we'll see that my editor is in my Universal System Resources bin nvim. Okay, so that is a summary of the file system. And as we mentioned, this is a standard file system. In this next section, I just want to touch on users. All right, so you can always see the users under, I'm going to say cat, and then I'm going to say Etsy, and then in here I'm going to say passwd. These are the users that the system has created. If you'd like to know more about users and about groups and the permissions and so forth, then check out my, once again, I hate to drop it, but check out my Linux security video. But in here we can see at the top we got the root user, we always escalate to root if we need to. Otherwise, midway, you can see we've got rad. That rad is the user that I'm logged in at the moment. We've also got test and YouTube, okay? They're down the bottom. But we've got another number of other processes you saw there. They've got their own users and so forth. We also know that if we want to say ls home, we've got some users in here, right? So I've got Boris, rad, test, and YouTube. Well, what if we wanted to create a new user? Well, I wanted to show you this because even though your distribution will do this out of the box for you when you install, you'll have a root user and then you'll have a standard user by default. Ubuntu, for example, will do that, and so will Fedora. Well, I wanted to just show you because this is an example of where you would want to use sudo or the superdoer privileges to escalate privileges and then create a new user. I myself is rad, I'm logged in as rad, and let's say I wanted to create a new user. And so I'm going to say sudo user add -m. This is going to create a directory, a home directory for the user in this /home directory. And we're going to also add this user to the wheel group. The wheel group being the big wheel, this means that they're also a super doer, a super user. Okay, and we can always refer to, just as a note, if you wanted to look at the sudo config, you can see that in etc, right? All of our system-wide configurations are going to be in etc. And so here we've got wheel, and then we're going to provide username, and we're going to say Windows hater, right? Because we hate Windows. What I'm going to do, I'm going to now give a password to that Windows hater user. So we're going to say passwd Windows hater. Okay, and now I'm going to switch into that user. All right, and so right now I'm actually in the root, but let's say if we wanted to change into my home directory, there's actually nothing in my home directory as the Windows hater user. Of course, your distribution would have created all of your downloads and music and whatever directory, but just want to quickly show one last thing here, which is if we say ls/lah, we can see that we have our bash profile and bash rc. If I'm going to, for example, run history, and we can see our bash history as well. So the important thing to note here is that each user is going to have a shell. So we can say echo the environment for the shell. Here I'm using bash by default. You can do the same thing on your system to see if you're using ZSH or fish or bash, for example. Nevertheless, I wanted to show you how you can create a user in Linux using the command line, and that kind of summarizes this section of the tutorial. You've learned about the core utils. You know at a high level about the Linux kernel. You know where your executables and binaries are located, right? And you also know about creating users and the overall Linux directory hierarchy. Final thing that we want to do, just very much touching on this because this is getting into more advanced stuff, and when you install your Ubuntu or Fedora, all of this is going to be set up for you. But ordinarily, I mentioned right back at the beginning of the tutorial, the Initsystem. I use systemd, and you'll find a lot of the time most of the distributions do use systemd. And so, for example, you might want to get the status on your Bluetooth. It's systemctl, system control. You can see the status of your system, your Bluetooth, for example. And so in here, we can see that it's running at the moment. The same would be for your Wi-Fi, for all of your different services. And so this is what your Initsystem is responsible for. You've only got to be aware of this because the thing is that you can do this all through the graphical user interface. Just important to understand. If you wanted to stop this, you can run stop, start, restart, whatever it may be. Finally, the last thing, and this is dependent upon the distribution. Recall that when we got to the package manager section, if we're using Ubuntu, we would do something like sudo apt install. If we're using a system like myself, like Arch, we would say pacman s, and we would update it with y and u, and then we could say the package name. So if I wanted to say install htop, I'm going to need to run that as root, and so I'm going to run sudo bang bang, just refers to the previous line. And so I'm installing, I'm logged in as window hater, but I'm a sudoer, so I can install this. Okay, so now this is going to be available. If we go and have a look at where is htop, okay, And so I can run htop. And here we can get an overall understanding of our system. We can see how many cores there are at the top. We can see the memory utilization, the swap utilization. At the end of the day, just wanted to show you, you need to be aware of your package manager. You need to keep your system up to date, and you need to use the package manager to install programs, okay? It's not, of course, as simple as that, but this is all you need to know to get started with Linux. Okay, and so just then I installed a program. It was that easy. I installed htop, and typically I don't actually use that many applications, especially these days with the advent of web-based or browser-based support. So everything pretty much has a version, like Google Docs has a version in the browser, Discord has a version in the browser. So it's super easy to get started on Linux and to install applications. Of course, you can install those directly from the standardized package manager, much better than with Windows, where you have to go searching for installers across the web. You don't know what you're downloading. So that's one really nice thing about Linux, is the installation process for the most part is a lot easier. Now, the question, what I wanted to drive home in this video is just that all these distributions, they have their own quirks, and some are better at some things than others, but ultimately they all use the Linux kernel, they all use the GNU open source library for tools and utilities. They all have, you know, a lot of the same attributes, and so it doesn't really matter where you get started, because everything that you learn, say on one distribution, it will be transferable to another distribution. However, that is a bit of a cop-out, right? Where should you start? You should start exactly where I started. Just get started with Ubuntu. You can download it, chuck it on a USB stick. I'll leave a link in the description. You can boot into a live USB, so you don't even need to install it on your system yet. You can just kind of chuck it into your laptop without wiping your existing operating system. Have a look around, see if you like the look and feel of it. Work with that for, say, 6 months. And then at that point, you might want to check out some other distributions. In my case, I use Arch Linux. The reason I use Arch Linux is that it's just a bit more up to date than Ubuntu. Ubuntu, on the other hand, is quite stable, and that's why I'm recommending it to newcomers. So go and download Ubuntu, chuck it on the USB. Tell me, are you going to get started with Linux? And I'd like to see you back at the channel soon. Thank you.